Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about tunnel boring machine. So let's dive right into it. Now, what exactly we are talking about here? Well, you have to understand this. We need tunnels. We need a lot of tunnels. Meaning tunnel is one of those things that allows us to basically pass any geographical limit. Meaning mountains, we can just penetrate the mountains. We don't have to look like go above it, go around it. It's like, nah bro, we can just go through you. So that's amazing thing. Many times the rivers are there and like, areas around it where it's like, let's say there's a lot of boat shipping. You're like, I have to make a very tall bridge or I can just go below it, tunnel. And one time you have to understand, but tunnels, like whenever you're talking about city people, they are thinking about like, metros and all that jazz. That's good, that's awesome. But you also have to understand, whenever you are talking about international tunnels, many of time they are using freight also. And freight is like a very big, importance for us. And if you can move one freight train, it is equivalent of hundreds of trucks. So multiple freight trains moving between two countries, so let's say UK and France, you can have exponentially huge amounts of trade going on only with one tunnel. So it's very important for public and freight. On top of that, there are also low intensity use, which we call utility tunnels. Basically, Elon Musk the weed. So utility tunnels are what we classify as sport tunnels. Sport tunnels can be happen multiple uses, like it can carry power lines, it can carry data fibers, it can carry some gas, it can carry some water, whatever have you. Like China is trying some extreme thing where they have like ultra high voltage lines directly going underground without, again, you can bury lines, but those are very expensive per meter. So this is a gas insulated high voltage lines, and this allows them to have very high voltage lines underground without costing too much. And voila, like they also have train tracks, so meaning the maintenance of these sort of things would be very easy. So there's a lot of use of it, meaning demand is far higher than the supply. Like every Tom, Dick and Harry wants tunnels, every Tom, Dick and Harry, if they can afford it. So how do we start? We start tunnel boring machine with cutter, the first thing that you see, basically this pizza cutter as you think. Now this defines the diameter of this. This is not like a milling machine where you have a diameter and then you can move the mill to like, make a larger stuff. No, this is one size, that's it. Meaning at the beginning of the project, you will decide it, like, will it be this size, will it this size, will it this size, and that's it. You cannot move it around, you cannot make it bigger than that. It's just, that's it. Now, how these are driven? Now, they consume a lot of electrical power, like almost few megawatts, as in like 7 to 8 megawatts, or sometimes even more than that. But all those electrical energy generally directly gets converted into hydraulic energy, meaning electrical motors directly driving hydraulic pumps, and hydraulic pumps is the primary power supply for all these sort of things. Basically, how this is spinning? Hydraulics. So it's using pressure for cutting and crushing. Basically, it's not cutting as in like, a knife. It's cutting like just dull edge going through. It's more of like shearing action. And this is one of the interesting thing about tunnel boring machine, is that harder the rock, the better they work. If you give them mud, they're like, I don't know this, I don't want to work here. You give them a hard rock, they're like, bro, I got this. So this is one of the interesting aspects of it. And they also have to create mud, because generally they try to go through some tough rocks, and even if it's like, low grade soil or things of that nature, you have a lot of stuff. How the heck you gonna evacuate that stuff? All those stuff goes into small slots that you are seeing. Those dump it into a bucket. That bucket generally could have a scenario where they could be pumping water or some sort of slurry that will make it into a quote unquote mud. That mud will be sent out for extraction. Extraction meaning away from this tunnel boring machine. And they could use vacuum lines if it's a very liquidy system, or they could use conveyor belt if it's a dry enough scenario. So that's how you evacuate. Basically, that's why you don't have to drain things from the other end. You can just like, I'm just eating through and pooping things through, almost like an earthworm. I mean, like that was, many people say that was the inspiration of this. So that's how the cutter works. It's using pressure. It does not use edge. However, they do dull after a point. So, but they are not using cutting edge as a like knife. They are using blunt edge. So that's how cutter works. Then we could figure out how the heck you're going to drive this. Like, you got the cutting part. How the heck are you going to go through it? Well, hydraulic pushers are used. Again, everything in the system works on hydraulics. So hydraulic pushers are basically to foot. Now, be mindful, it's not necessary there could be only 2 foot. There could be many more. There could be 3, there could be 2, there could be multiple small ones. That's up to them, designer, manufacturers. But generally, they have foot structure. That foot structure generally jams itself. It's like, bam. Now, when it jams itself, of course, the calculation would be done how strong the tunnel wall is. Now, that jamming force gives them the anchor point. On those anchor point, master cylinder pushes themselves. Basically, the new anchor point would be selected. Okay, the driver, that's what the driver does. The anchor is now put in the place, and voila, it slowly moves the master cylinder, and that master cylinder is the one that is driving the main force. Like how the heck you put pressure on a rock, those are the hydraulic cylinder. The bigger those puppies are, the more stronger they are. Or in some scenarios, they will have a lot of small ones to create a grand force, or sometimes they will have some big daddy ones. So that's where your main force is coming, and that anchor is the part where it's like, that's how you are moving through. It's like, put them, move forward, pull them back, put them, move forward. It's almost like swimming, like literally. So that's how it pushes itself. It does not require being pushed from the back side or pulled from the front side. It's like I got this pen. Now you have to understand, now you have 2 points of vector, or again depending how many system you have vectors control. This allows you to cause what we call differential pressure, meaning you can move in 3 dimensions, meaning left or right. Now it's option available for you, because be mindful, reality is like many times geography does not work for you. You may be like, dude, this rock band is perfect rock, it's not too hard, it's not too soft, it's amazing, we can move very fast, and you're like, okay, tunnel boring engineers are like, bro, this is awesome, let's study those layers so we can figure out properly. And the tunnel would be like, it has happened, I'm not making this up, this is real world, where tunnels are like going up and down, and many times you are like, dude, even though the tunnel like A and B are like in a straight line, you literally will have curve. That's the reason. Generally geography is like a very weird thing. You will rarely find like absolute 90-degree angles. So your tunnel has to have the ability to steer itself. So that's done by the basically this anchor force. And this steering is done in 3 dimensions, because you may have to move not only left and right, you also up and down. So in those sort of scenario, this happens. Now be mindful, this is exaggerated animation. It does not move that much. It's like very little, but it does get the job done. And cutting action needs pressure. So that's why these master cylinders are idiotically powerful. And like if you are figuring out like where the heck megawatts of power being consumed, those are generally the primary candidate, not the cutting head, but that master cylinder that's consuming a lot of power. Like this, it's heavy, it's big, it does take some energy. Those master cylinder hold my beer. So that's how you drive these puppies. So how do we make the tunnel behind it? And that's why it's called tunnel boring machine. It's not called boring machine, tunnel boring machine, because it completes the tunnel behind it. Now, if you just want a tunnel, especially a utility tunnel, that's it, done, go home. If you want like a roads and all that, of course, the second crew will come in once you have completed the tunnel. But generally, these are like done very quickly. These tunnel boring machines, even though we think they are very slow, but compared to how we used to do it hundreds of years ago, it's like, damn. Like the tunnels that we can dig today, even with jamming and blockage and all that jazz, where tunnel boring machine could be stuck for 2 or 3 years, still would be faster than any old method. It still would be exponentially faster compared to any blasting method. So flat out, that simply happens because of this casting. Basically, it can create casing behind it. So tunnel is getting finished right after you are making the tunnel. So using hydraulic arms and ramps, because you do require some pressure here. So hydraulic arms will allow you to move the segments. Now how the heck you are bringing the segment, that's up to you. You could have a conveyor belt, or generally because of the big units, generally there will be a train line sort of. Those train line will keep bringing the units there. That unit will be selected. Now how the heck you pull it up, something this big, huge, vacuum, because again it does have smooth surface and very large surface area. So you can actually have vacuum that can pull it up. You rotate it where you're supposed to place it, you place it down there. So curve segments are used for twisting and turning. That's why you will rarely see absolute 90-degree angles, because if you had segments that are absolutely 90, all the tunnel boring machine could do is just go straight. It can't turn, because if it turns, it will have gaps in the casing and tunnel will collapse at the gap. So fundamentally, it needs tight casing. So how the heck you make tight casing for something that like you are fabricating this somewhere else, not on spot? So how the heck you make it? You make curves into this. Now even the best angle where you see it looks almost 90-degree, I can guarantee you, if you can get a straight edge, you put it there, you're like, oh, it's 89-degree or it's 88-degree. It will never be absolutely 90-degree. They will never design it that way. And then they have a wedge piece. Like once you put, let's say, all 4 pieces, the 5th piece, the final piece will be a wedge shape. Now this wedge shape will be ramped in there, because this is creating the hydraulic pressure lock, meaning this gasket has to be compressed. And not to mention, you also want the gap between these cement blocks to be almost negligible, because again, water leakage and all that jazz. And be mindful, all those bolt hole also has to line up. So it does require that final ramping action to seal it up. So it's almost like in pressure and compression. So perfect spot for concrete. So these are manufactured on top of land. They are marked rated as like, they will mark it as in like this has to be in the 10th ring from the start. It has to be that precise. You cannot just like, oh, I'm going to push this part here or there. And if any breakage happens, which does happen, if you have hundreds of these units, you could have breakage, failure, gasket failure, whatever have you. New block has to be specifically forged with that. So these are serial numbered and handled. If you are dealing with some rough level contract, they will have a scenario where each tunnel segment ring would be left, one would be right. Like, what's the point? If you're going straight, put left, right, left, right, left, right. If you have to turn, left, 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 left. If you have to put right, 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 right. So that's how they balance it, if they have to be generic about it. So prefabricated concrete blocks and wedge shape allows that pressure lock, and that's how you get the full tunnel. Meaning, once this puppy is done, the tunnel is actually ready for use. Now, what do you do after that? That's up to you. Meaning, you can literally wait for the tunneling process to be complete, and then the railway crew will be like, okay, they're gonna lay down the concrete slab, bury tracks into it, and voila, railway track. That's it, done. Go home. So road also can be like, of course, they will create a balance layer. It's not a good idea to have a road that curves. So all those things can be done. So that's how it works. And these are the another aspect I was saying, like multiple foots can be there. These are multiple small foot. That's how it's creating that pushing force. So you have to understand this. Every time, every documentary you watch about these things, you will never get a fixed price. The reason for that is, even though we are making boatload of them and boatload of diameters of them, these are what we classify as tailor-made equipment. Meaning, before you go to the company, like be it India, be it America, be it weed company, you have to start what we call target site study. Meaning, this is where we want the tunnel, this is the conditions of it. That data has to be fed by from the engineers to the company who's actually designing the part, and then they're gonna start building it. They will not start before that. That's why these projects could take time. And even though their companies, basically German designs, they could have like hundreds of catalog option, it will still take time, because they are not like, okay, control C, control V. It's not a PC part. These are huge parts. So they have to bring those parts in, align it, test it, do all that jazz. And again, disassemble for transportation to your, like, let's say from China to India, they have to, this is from China. They have to do that from Germany. Again, same thing. You build it all together, test it, disassemble it, transport it. That's why tunnels take so much time. Like majority of the time is just being consumed with that. So target study. What do we study in targets? Well, soil, rock strain. Now this is one of the ironic part about tunnel boring machines. You give them hard thing, they're awesome. You give them soft, they collapse. Like fundamentally, these things are very dangerous if you're going through mud, and they are completely different configuration with completely different shield guard, basically the casing behind it. Because again, tunnel does have some open space where you just are exposed to the raw tunnel before the like cement part is done. There is a gap there from the cutter head and the completed cement. This vacuum, not vacuum as in like this exposed tunnel, does require some supporting. Many of these things who are designed for working in those sort of environment where it's completely unprotected and the rock is just not stable enough, they will literally have rock bolt driller just behind it. It's just putting rock bolts to stabilize that. Then there will be a met mesher that's gonna put met mesh there, and then you're gonna have a shortcut sprayer that's gonna put shortcut to stabilize it. Then you're gonna have the main cement. Again, tailor-made equipment. So that's why you have to study the system, where it's like, what is the soil condition, what's the rock condition, and then the trouble with all water table. What's the water? So tunnel curves and bend, those also are defined. Like basically, do you need a tunnel boring machine that can like took your drift, or do you want a tunnel boring that's like little bit is more than good enough? It's like, if majority of the lens is directly straight, why bother is investing in like super flexible turning head? All those things have to be calculated. Now diameter is the biggest part here, meaning this will be expensive, this will be idiotically expensive, this will be free in comparison. So one thing you have to know, diameter price does not go like, let's say this is the lowest one, this is utility tunnel, this is 1x, this is metro tunnel, this is 50x, this is a idiotically large tunnel, this could be very high. Like let's just call that very, very high. So generally 14 meters or up, those are ludicrously large tunnels. Many times, because of the cost, because of the reality of having a machine that huge and working, many times it's like, unless that project is idiotically high value, they will never do 2 of these tunnels. So generally what people do, especially in India, especially majority of the world, is that they will have 2 tunnel boring machines, basically 6-meter diameters, 2 of them, like upline, downline, done, go home without going bankrupt. Or if you are like smoking weed, you're like, I'm gonna do Metro's work on like a freaking utility tunnel. It's like, there is a reason we use this. And we had hundreds of years of research and development to figure out, like, bare minimum we need that much for Metro. You can't have Metro in this. Like, and you cannot move that many people in cars. These are, again, these are amazing tools. These are desirable. Many times you could literally have two big tunnels like that, especially if they're connecting two continents, and one small one like this would be drilled between them. Reason, that's an emergency evacuation tunnel, that's a utility tunnel. Again, safety inspection tunnels, those things are awesome. That's why it was built. That, again, the boring company did not build this machine. This is a control C, control V machine, meaning you can buy it, you can rent it. So these are tunnels are very desirable, very useful. But for utility, for transport, you use this. For very large transport volume, you use even bigger one, or you use two of these or four of this. I've never seen any four one. If you know, please comment down below. So that's the whole point. Each things are tailor-made for project, meaning you do that analysis, then you start building the machine. Then you figure out how the heck you're gonna transport the machine. So this was my presentation on tunneler boring machine. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.